Hello students, this is Mr. Boggs. We didn't quite get finished with chapter 3, so what I'm going to do over the next few days is create some videos from the questions in exercise 3.7. So what I'd like you to do is, as I bring a question up, first thing I'd like you to do is just pause the video, read the question yourself, and see if you can actually do it on your own. And once you've done that, then restart the video and just check the answer. Alternatively, if you have no idea how to start, wait till I show you, say, the first step, and then you might think, I know what to do next. Stop the video, see if you can complete the question on your own, and then watch the rest of the answer. So basically, you should be sitting there with your exercise book, your graphics calculator, a pen, a pencil, an eraser, etc. So you can actually be doing mathematics and not just watching me do it. Okay, let's get started. I'll read out the question first. The number n of horses with a disease T days after starting a course of treatment is given by, and there's the equation. And the first question is determine the number of horses that have the disease initially. So pause the video and have a go yourself, please. Okay, let's assume that you've done that, and let's go through the solutions. So first off, you've got to figure out what they're actually asking. So initially, basically is saying, it's another way of saying, what's the value of n when t equals 0? Initially means when time is 0. So all we have to do is, in place of t in the above equation, put a 0. Well, notice, by the way, I turned this into log to the base e rather than natural log. I just find this easier to think about natural logs if I can actually see the base. So you don't have to do that, but that's my preference. Okay, so the next step, obviously, e minus 0 is e. Log to the base e of e is 1. And therefore, we've got the answer to the first question. N equals 150 horses initially. Okay, let's move on to part B. Okay, part B says, how many days after starting treatment are there 100 horses with the disease? Give your answer to the nearest day. So once again, stop the video. Try this question on your own, and once you've had a go at it, then watch the rest of the watch the solution to this. Okay, let's see how you went with this one. So in this case, they're telling you that n is equal to 100, and then we have to solve it for t. So basically, just solve the equation. So substitute 100 in place of n is step 1. Okay, what I've done there is I've basically said 100, take 100 from both sides to give you that equation. I've also written the natural log on the left-hand side. Okay, I divided both sides by 50. So notice if you have an equation like this where there's a 0 on that side, if you got a coefficient out the front, effectively you can just get rid of that because you divide both sides by 50, you end up with the same equation without the coefficient. Now let's rewrite that as an exponential equation. Oh, I didn't change this into log to the base e. I should have done that. And that gives us e to the 0, which is 1. Well, first off, looks like I rearranged it to get the t by itself. And then e to the 0 is 1. And there's the exact answer. Okay, well, e is 2.718281828. So that gives us t is 1.7. So to the nearest day, it took 2 days to get down to 100 horses. Okay, on to part C. Assuming that the model is only valid until the horses are cured, determine the exact value of A. So this question's worded a bit differently to ones you've done in the past. So again, stop the video, have a good think about it, and see if you can do this without any assistance. Otherwise, just watch along. So effectively, what we're trying to do is find out what's the biggest value of t. So to do that, we're basically going to say that the disease is over when n goes to 0. So effectively, question C, the way it's worded it, is to say we're going to find the value of A when we don't have any more horses to cure. So we've basically put 0 in place of n and solved the equation. So if you want to try that on your own right now, you can stop the video, see if you can finish it from here. Otherwise, just keep watching. Okay, so step number 1, what I did is I subtracted 100 from both sides to get the 100 on that side, making it negative 100. Step 2, I divided both sides by 50. So negative 100 divided by 50 is negative 2. Step 3, I rewrote it as an exponential equation. So this time I do have log to the base e. So e to the power of negative 2 equals e take t. Bring the t to that side to make it positive. Bring the e to the negative 2 to that side. And this equation here becomes that equation there. And therefore, that's what A is. Since it asked for the exact value in the question, we stop just there. Okay, so that is part C of the first question. By the way, in the textbook, if you go to section 3.7, the first example in the chapter is exactly the same question as this with slightly different context and different numbers, but it pretty much goes through the same steps. Okay, on to question D. Determine the average rate of change of n over the first 2 days. Give your answer correct to 2 decimal places. Well, we haven't done many questions asking about average rate of something, so what I've done is I've gone and done a little example, a simple example, so that gives you some idea of exactly what you have to do. Again, if you think you know what to do, stop the video and have a go. Otherwise, here's how you find an average rate of change. Okay, so I'm going to make up some numbers. I'm going to assume that there are 70 horses with the disease at the start and only 10 horses with the disease 4 days later. So there are 60 fewer diseased horses after 4 days. So on average, all we have to do is say the final number, which is 10, minus the original number, which is 70. That gives us 60 horses, negative 60 because it's gone down, and you divide by the 4 days, and what it's telling you basically is on average it's gone down by 15 horses per day that have the disease. So here's the formula for finding the average rate of change. It's just the final value minus the original value divided by, in this case, the number of days. So I'd like you to apply that same formula to this question. So again, you might want to stop the video and see if you can do that on your own, and then turn it back on and check your answer. So once again, there's the formula just there. Okay, so in this case, it's the number of horses with the disease after 2 days, which is going to be 0. Sorry, that's wrong. Just the number of horses after 2 days that had the disease minus the number of horses that had the disease originally. So those numbers have to be plugged into that equation. And that's what we come up with. And then get out your calculator, do the calculations, and you get negative 33.27 horses per day. So that's the average rate of change. Each day on average, 33.27 fewer horses have the disease. Okay, moving on to the last step of question 1. Okay, the number of n of horses with the disease. Okay, don't need to read that. E, determine the exact rate of change of the number of horses with the disease after 2 days. So in this case, the difference is they're asking for the exact rate of change, not the average. So if you think you know what to do, stop the video, have a go on your own, and if not, let's go through the answer. So basically, the exact rate of change is just a fancy way of saying find the derivative of the function, because derivatives, basically, that's what they tell you. The exact rate of change for any particular value, in this case, any particular value of t. So there's the derivative just there. So the derivative of 100 just goes down to 0. The 50 just stays because that's a coefficient, and coefficients just stay when you do derivatives. The derivative of the inside function, e minus t, is -1, because the coefficient on t is -1, and the derivative of the log of something is 1 over something. So there's the formula for the answer. Now, by the way, you could just leave it like that, okay, and just substitute 2 in for t, so that's quite okay. What I did is I multiplied this by that number there. I just multiplied it by the numerator to get that version, so that version's also okay. Let me move this down. And the textbook actually has that answer. So what they've done to get from there to there is they said, we want to have the t in front. We don't want a negative sign on top. So they just said, let's multiply top and bottom by -1. -1 times -1 is 1, and that gives you positive t minus e, and that is the expression for the answer. And then when t equals 2, you get that is the exact rate of change for that particular value. And that is the end of question number 1. So if you didn't get those questions on your own, what you might want to do is maybe this evening or tomorrow, just have another go on your own. I guess the best way to actually practice stuff is to leave it for a little while and then go back and have another go. And that is the end of the first video.